All right. So welcome everyone once again to the Hudi Community Sync for the month of August. If you are new here, Community Sync allows community users and developers to meet, interact, and exchange ideas on Apache Hudi and how it is implemented in various organizations for the data lake or data lakehouse architecture. In these sessions, we usually like bring out some of the user stories, how people are leveraging Hudi, some of the complex steps that they had to take, the lessons learned. So it's a really good idea to tune in and learn from these sessions as a whole from people who are productionizing Hudi. Today we have yet another interesting presentation from Uber Engineering. During this presentation, our speaker, whom I will introduce in a few minutes, will discuss on how Uber uses Apache Hudi to build low latency solutions for complex data workflows. Before we go into the actual presentation itself, we'll be quickly going over the community stats and updates, what has happened in the past month since we last met, and then we'll start our session and end it up with a quick Q&A. Since this session is also live on LinkedIn, feel free to post your questions in the chat, like I said in the beginning of the session, and we can take it asynchronously as well from there. So yeah, just get involved and let's be interactive. All right, so let's jump into the community stats. So in the last month, we have had over 75 PRs, and a lot has been brewing on the Hudi project side lately. In the last month, we have had two major releases. 0.15.0 was released, and the Apache Hudi 1.0 vision is also coming to realization with the Beta 2 release. You can read about all these interesting features and updates that are coming with these new releases on our website, hudi.apache.org, under downloads. We have had 39 authors who contributed to these PRs. It's always a great diversity of people. We also closed 28 issues during this time, and there are also new PRs being worked on right now. In terms of the community growth number, we are around at 4392 Slack users. Slack is a great place for the Hudi users to bring up any discussions, issues while implementing Hudi, knowledge guides, and there are also PMC members available to chat with you. So if you're really interested in delving a bit more and learning from the community in general and contributing back, the Slack channel is a really good place to be there. I'll share the link in the next slide for you to join there's a QR code for you to just scan and join the Slack channel. On GitHub side, we have now 5,300 plus stars. So really good momentum and good vanity metrics over there. And of course, I mentioned about the 39 contributors who landed the PRs last month. We also are super excited about our newly released Hudi RS project that we released last month. Basically, it's a native Rust library for Hudi, now with bindings to Python. So the Hudi RS project, the motivation of the project is to enable Apache Hudi table users for diverse range of use case, mostly in the Rust and Python-based ecosystem, without the need for any JVM or Spark, right? So that's really a new set of use cases that opens up as well. So please check out our GitHub repo and star if you like it. Also, if you're looking to get involved in any form, please reach out to us or start a PR. There is also a really nice contribution guide that we started. So, it's a good momentum and good time to be. Here's some more resources for you. We frequently post in our LinkedIn and Twitter. It's really good to be updated with the community in general. Here's this QR code to join the Slack channel. With that, let's welcome Ankit, who is a senior software engineer at Uber. Ankit, I'll just add you to the stage and you can take it over.
Thanks, Dipankar. Hey, everyone. Thanks for joining. Welcome. So I'd like to give a very quick introduction about myself. I'm currently working with Uber. It's been more than 4.5 years that I'm working with Uber. And in total, I've worked for more than 10 years in the industry. I'm part of a team called Core Services Data Engineering at Uber. We provide data solutions to different verticals like payments, risk, compliance, etc. at Uber. And today I'm here to talk about how we scale some complex data workflows using Hudi. So without further ado, I'll get into that. So this is the agenda for the talk today. I'm going to talk about the challenges, the RCAs, how we tackle those problems, some wins, and we'll have some time towards the end for Q&A. All right. So before I talk about the challenges, I want to set context on the use case. So the use case that we had was pretty simple. What's the collection from a trip or an eats order? So what this means is when you take a ride, how much money has Uber collected? Uh, Pretty simple use case to put in a sentence, but once you have to compute these matrix, it can get very complicated. What I mean by that is you can take a trip, you can add a refund, the driver can also raise a dispute, you can add a tip, you might travel to a different location than the original location which you requested, and you might not even settle, right? So there are so many possibilities here, and add that with different products that we have, that makes it a very complicated workflow, and doing it at scale has its own set of problems which we'll discuss next. So these are some of the challenges that we faced. One was read and write amplification. So for context, like we were processing somewhere close to 2 million records in a day, and as I mentioned, a trip which was taken maybe 3 years back can also have a change in its status. Because let's say you took a trip 3 years back and you didn't settle, but now you want to use Uber product again, so you will have to. And that basically means you will settle the old arrear, and we have to account for it. So how do we know that this new transaction that you're doing, it's attributed some old trip or order that we've already processed? We did some statistical analysis, and we identified that most updates are happening within 180 days, and that's what we used to do. So you're reading 180 days data blindly and you're writing again, regardless of whether there were actually any updates or not. Then we had a very long running process, somewhere close to 20 hours, and that has its own set of problems. If it fails, you're basically stuck. It's unrecoverable. You have to wait for the next instance and make sure that it runs. We also had a very huge pipeline DAG, more than 50, 60 tasks. I'll show it to you in the next few slides, which again, it's difficult to maintain, manage, and make changes to such implementations. The development cycle was very cumbersome, long, because of the things that we discussed, right? You have to make some change. You need to ensure it's not breaking something existing. You also need to ensure that you're adding it at the right place, processing data efficiently, uh, not add to the existing 20-hour runtime, right? And then we had some data quality issues because, of course, we were not processing all the data because, as I said, right, we were processing 180 days, but the updates could have come for orders much before that time frame, right? And overall, it was not good for developer productivity because you have lengthy dev cycles, you have maintenance heavy process, and bugs. That's not good for dev productivity. You're focusing more on operational asks as opposed to doing new things. Um, so this is what our DAG looked like. I mean, this is not the real pipeline, but I've tried to uh, recreate a figure which kind of resembles what we had at our end. And this looks messy, but we really had something like this. This is what a dev cycle looked like. Again, like it's pretty standard stuff, but we had a couple of bottlenecks like identifying where to make changes because you have so many places where you might have to make change. So that's a very involved process and highly iterative. Data validation again, because you're dealing with data and you have so many cases to cover, and also ensure that you're not breaking existing things. You're also ensuring that the new additions or changes that have been introduced are correct. You need to do thorough data validation, and that's also can be very expensive in terms of time and compute both. Now, to summarize, we had these challenges, right? We had huge DAGs of pipeline. We had a lengthy development process, long-running pipelines, data quality issues, and bad dev productivity. So we asked this question to ourselves: How did we end up here? And then uh, the next exercise was to identify what were the uh, what were the things in our process that were causing these problems or challenges. So we use SQL a lot, and SQL is the choice of language for processing data. But we were in a situation where it was not scaling for us. The transformations that we were dealing with were getting too complex to express them in SQL. Uh, so we were still able to express it in SQL, but it resulted in like multiple granular SQLs, breaking the SQL down or creating multiple intermediate states, which will basically load up your logic. Um, so that was one issue. Part of it was SQL, part of it was also the processing logic or the transformation logic that we had. The unit testing is something which everyone should do, but very difficult to achieve with SQL. There are different SQL engines. I'm talking in context of big data, so I'm assuming Spark, right? So unit testing SQL is difficult. You can have an in and out kind of unit testing, but if you want to get into granular computation, that is just not possible. Similar to unit testing, debugging is also difficult for the same reasons. Observability is also something tricky to achieve, I would say. If you want to know how a particular piece of code was executed, uh, unless you go to the Spark logs and have some way to emit particular matrix, compute and emit those matrix, it's very difficult. Then another thing, which again leads to the problems of big pipelines, is tight coupling of data and logic. What I mean by that is if you have to compute some metric related to amount, you have to write a SQL query which references that column amount, and that may be different or that may be available at a different granularity in some other intermediate state. So you end up creating duplicate logic at multiple places, which again leads to redundancy and lengthy workflows. Explainability is also something that can be problematic for complex workflows like mine. We had 50, 60 tasks. So now you have a final table. If you want to trace why a particular row is in a particular state, unless you know everything by heart, you can't do that. Or if you have to do it manually, you can assume how painful that could be. Then we had complex rules, as I discussed. These complex rules were by the virtue of the business. We have multiple products, different scenarios that occur due to it. Then second thing is due to how the data that we were processing. So it's raw data coming from services. It's highly nested, uses a lot of complex data types. So if you have to express that in SQL, it can get pretty complicated. Then at the top of it, we had multiple such business logics, again, owing to different products, different scenarios. And these do change and evolve. So your business change, your business evolve, you have new product, you remove some product, you change certain behavior of your products. You have to make changes in these processing logic at your end and ensure that you have a process which can accommodate for these changes, and you can iterate over these changes with a good enough pace. Then on to, in terms of data processing, there are I think these are usual suspects. Table scans are expensive. If you have too many joins, those are expensive. Shuffle is the root cause of all of this, which is like the most expensive operation in big data processing. How you're handling late arriving data can also lead to inefficiencies or inaccuracies in data processing. If you have to do any sort of updates, you have to do kind of self joins, which are also very expensive by nature. So we had identified all of these issues, and then the next step was okay. Uh, how are these contributing to the challenges which we discussed earlier, right? So this is kind of a RCA matrix. If you think about, let's say, big DAG, right? So you have complex and too many rules. You have SQL, which is kind of scattering your processing logic, how you're processing the data. So these are basically contributing to big DAG, and like there's no one reason for the symptoms that we were seeing, right? A lot of things contribute together to the state that we were in. So once we identified this, then the next step was okay, you've broken down into granular problems. So how do you solve these? So we decided to tackle these problems by uh, changing the data model a bit. We definitely wanted to process data incrementally for completeness and for efficient processing. We wanted to reduce the shuffle based operation wherever possible. I'm not saying you can eliminate them completely, but you can still, to a great extent, reduce how much you do that. And of course, because we thought we not like we were in a situation where our transformations or business logic was getting too complicated for SQL. We wanted to move to a more like functional rule-based uh, processing paradigm. And so these were the things that we identified that this is okay, this is what we want to do. And this is where Hudi comes into the picture. So we wanted to leverage Hudi, like incremental processing is something which is synonymous to Hudi for a lot of people. So we wanted to use Hudi for different requirements, like for efficient and complete reads. We wanted to use Hudi's incremental read capabilities. We utilize Delta Streamer for that. For efficient writes, again, Hudi offers upserts. There's also indexes, materialized indexes like record index that we want to leverage for performing efficient write operations. We had use case for merge, so we ended up using custom payload classes, and for processing data as functional, using functional coding and based on rules, we used the custom transformer. So I'm going to talk about these at more detail in the subsequent slides. Just wanted to flash this for everyone. So let's go step by step, right? So you wanted to read data incrementally. This is the simplest thing that you can achieve using Hudi if you have a source which can support this. In our case, in Uber, we have a huge data lake. All the services, transactional databases, data usually lands in our data lake eventually. It usually follows the route of CDCs. It goes to Kafka and then it finally reaches the data lake. And these data lake tables are what we call raw data tables. These are inherently Hudi tables. So first step was to read data incrementally, which is okay. This is the simplest thing to do. You use Delta Streamer, you will be able to read data incrementally. But then that doesn't solve all the problem because, okay, I have, going back to my use case, I have a new transaction coming in for a record for a trip which took place 3 years back. I need to be able to attribute it to the correct trip, and then I need to recalculate that whether the trip is now settled or not. So in order to do that, I need the complete data points for that trip. So for that, we did a data modeling exercise where we created an intermediate table where we collected all the related records together in a single row as complex data types. So, for example, a trip which was, let's say, took place on 4th of March, but you have a new transaction coming in for that trip. So you add it to that trip or an order, and now you have like all the transactions. So if anyone has to, recompute, they have all the data together at a single place. And because we're using Hudi, this is also a Hudi table. Anyone who's reading incrementally from this table will receive this order one record also as incremental read or a delta read by the virtue of this table being Hudi and this record being mutated. And again, we use the upsert capability of Hudi here. So just to recap, we created intermediate table which would drive our data processing where we collect all the related orders together. And this is a crucial exercise because a lot of time I've seen people strike out or don't consider incremental reads or delta technologies like Hudi because they think they're not able to model their data that way. But I think uh, something like this can probably help in a lot of use cases. Then second thing is storing the data as complex data types because anyways we are planning to process data in functional manner. So complex data types work well with functional code. This also ensures zero shuffle for any downstream use case. So now that you have all the data together, you don't need to scan multiple partitions, bring the data together, do any shuffle operation. You can basically do map side operations, which are narrow transformations, highly efficient and performant. And in terms of Hudi, it solved our read and write amplification. It helped in reading data incrementally, performing efficient upserts, and also process data based on changes or mutation. Moving on. So I talked about this data modeling exercise where we are basically merging data together, right? Now, how do you do that? You have, let's say, an existing record, which looks something like this, and you have some new attributes being added to this record in your delta. So you essentially have to do a merge operation, and if you have to do it in SQL or any other way, you basically need the reference of your existing record and also the incoming delta. Behind the scenes, when you execute it on Spark, let's say, this is what happens. You have your source table, you read data incrementally. You have a small, data frame or RDD for your delta, and you also have to read your target table. You need to do a self join, so you will probably be reading a lot of your target table, identify where the corresponding record is. Then there's the shuffle that you have to do, and then you will do your merge. It could be SQL, functional, whatever, and then you will finally hand it over to Hudi. So you will transform your data, and then you hand it over to Hudi. That okay, now this is what I want to write. Then Hudi takes over. But then what Huri does also for case of upserts is it has something called as payload class, which dictates what should happen in case a record has to be inserted or updated. So the default behavior is based on the value of your pre-combined key. Hudi picks the latest record and updates the storage with the new record and inserts data for something which has no reference in the storage. But if you think about it, this is also kind of a shuffle operation. Hudi is doing an index lookup, trying to identify which records have an update, and then do a merge, not merge in this case, like replace operation. So what we decided was that probably if we offload the merge part of our transformation to the payload class, that will help us save this shuffle. And that's exactly what we did. So you read from your source table, you transform your data into the schema of your target table, and then you hand it over to Hudi. And we created our own custom payload class, which implemented how the updates should be handled. And the way it handles the update is it does the same merge operation, but instead of doing it at the user transformation, we are doing it in the payload class, which Hudi anyways would be doing. And the index lookup is anyways efficient than scanning the table. So this is more performant than the normal self join. This basically reduce the whole self join operation, which if you think about it, if you have a append only table also, it's like O of n complexity. Your source data will keep, your target data will keep growing, and your lookup operation will get more and more expensive over the course of time. Yeah. So this is what a payload class implementation looks like. This is a pseudocode, but you have to extend a base class. You can extend any implementation of the classes also, like the default class that Hudi uses. And then there are these methods: get insert value, combine, and get update. You can update, you can implement your own logic here, and that's how you can use this. And there is a config in your when you create a Spark application with Hudi, wherein you can specify that I want to use this class instead of the default class. Yeah. Uh, Again, to recap, so where we are at now with this is from our payment service to our messaging queue to raw data. We have created an intermediate table which is reading data incrementally, performing efficient merge and updates. And now this table has all the updates flowing in. So any consumer to this table can react to any updates, upsets. So including new records getting added to this table and existing records, which signify a trip or an order, gets an update. So as a next step, I want to talk about processing, how we process this data. So as discussed earlier, we had a lot of issues with SQL. So we wanted to focus on the transformation logic, make it kind of the first class citizen. And for that, we came up with a rule-based processing framework wherein you define your transformation as set of rule, which is a set of condition and action. And that way you can club related transformations or rules together. If you're reaching some unreachable state, you can flag those. You can achieve high level of customized logging to get greater observability and also explainability. uh, in theory, if you log all your data transformation at each step, you can visualize how your data mutated over the course of time. And we use it, of course, we use functional programming with this, which means we anyways had complex objects. So instead of operating on those with SQL, you operate on those as objects using functional programming. And it also supports testing and also the logging that we spoke about earlier. So in the next slide, I want to talk about how to do functional programming first of all, right? So we wanted to do all of this, but how do we do this with Hudi? Because we also want to use Hudi for reading data and writing data. So Hudi has something called as transformer, and uh, there are different kind of transformers. SQL is the most common one, I will say. So basically, what happens is Hudi reads the data, and then you provide a SQL. It runs that SQL against your data, the incremental data, and then you transform the data, and then you hand it back to Hudi, which writes the data finally to the storage. So custom transformer basically intercepts, and instead of running a SQL, it hands you the data set of the delta records. And now it's up to you how you want to, do your transformation. You can do that here. You can even do here .sql and do it in SQL. And then you transform your data set and pass it back to Hudi. And then it takes over, and then it uh, executes the right stages of the job. So how we integrated the rule engine framework was we used Delta Streamer plus custom transformers. So you have your input table, it reads data. The delta will come in as a data set of rows. And then we cast it as a strongly typed object of particular class, which has all the columns of your input, as well as some additional columns that you probably want to generate. And then we pass it to the rule engine, which consists of a network of rules, and it knows how to process these rows, how to what should be the order of execution. Like if there are dependencies, like if you see here, rule 4 depends on rule 2, which in turns depend on rule 1. So it will only execute rule 4 after all of the dependent rules have been executed. And finally, it again produces a row object, which can be then written to your final output table. In terms of the details of the framework, although I won't get too much into the detail, but to give a gist, you basically implement your conditions and actions. So conditions are again like let's say you have this class object which has a couple of columns, and then you create these classes called, let's say, my condition class 1, and then you implement a function which will evaluate to a true or false boolean, and if it's true, then you execute the action, and the action can mutate the object within the existing properties. You can't add new properties. That's how we control the execution. Then we also allow people to create configs of these rules so that they don't have to worry about the boilerplate code on instantiating the rules object, creating the root network, etc. So the config basically takes care of that. In terms of the overall flow, what developer needs to do is they need to like write the functional code for their conditions and actions, and they can define their rule network and rules as config, and check that in either into the repository or some config store. And then when you're using Spark for processing data by virtue of Delta Streamer, you can plug in the rule engine code in the Delta Streamer custom transformer, custom transformer class, and then you basically pass your input data set to the rule engine, and it processes the data and then passes it back to Hudi to write to the table. So the final state is this. So we were here where we had created this intermediate table. So now downstream, we have another process which reads incrementally from this table, and it gets all the data, all the rows that have any updates or are newly inserted. And then the rule engine processes the data. It produces a lot of custom logs that are used for emitting matrix, which gives us observability on the health of the rule engine, and also the overall process. And then finally, it writes to another, sorry, the final table, which is again a Hudi table. Yeah. So in terms of when, so we had this process which used to take close to 20 hours. We were able to bring it down to close to a 5 hour runtime, which is a 75% improvement in terms of the execution time. We had no testing. From that, we reached to a state where our transformation logic had a 95% test coverage. The single run cost was down by 68%. We had data completeness wherein like we were not processing data based on some statistics or heuristics, but any update we were processing it. We had reusable logic, so like that huge stack, although it was not just because of rule, it was also was due to some enrichments on dimensions, but that huge stack we were able to reduce it to more reusable component. If some change comes, we know that changes, let's say in some refund logic or a tip logic, we can directly work there instead of having to work in a scattered SQL DAG. It improved the dev productivity a lot. Of course, like the initial effort was high, but for subsequent iterations, the developers can focus on the piece at hand. You have unit testing, you don't need to run the complete data validations. Unit testing can run very fast as opposed to the data validation that requires running the whole pipeline. We also improved the cell join, which can be extended to other pipelines. So if you think about a merge, even if you're doing something like average, sum, count, uh, if you're generating these kind of matrix by doing the cell join, that can be highly optimized with custom payload class. And we also had a generic rule engine design, which can be used with without Hudi also with, let's say, Spark or Flink. So yeah, I think that's pretty much it from my end. If there are any questions, probably we can take those.
Thank you so much, Ankit. That was really insightful. I really enjoyed getting to know like the ability that you use for like custom transformation and kind of these are really complex logic and the rules that you kind of have as well. I can imagine at larger scale it's only like complex to deal with it. So I
Yeah,
think it's great to see that in action and how kind of you have leveraged these capabilities that Hoodie has to offer. So yeah, let's quickly take maybe a couple questions from the LinkedIn comments.
sure,
And I also have a few of mine, and I'll be sure to ask them as well.
sure.
So we have a couple minutes. So I think the first one is for from Jason. He says for that intermediate table where you are grouping transaction from orders in different dates,
Mhm.
are you using a custom record payload class to handle the upsert logic?
Yeah. So
Okay.
because you have to merge, you have to do a cell join.
Hmm.
So one thing, like we actually did both. Initially, we were doing a cell join, and we started seeing the runtime increase. So we did a deep dive, and we saw that this cell join operation is getting being the root cause. So then we decided like what can be done to do that, and based on some community syncs, we got to know that there's this payload class that can be implemented. So we ended up doing that, and that I mean, for a close to 1.5 hour runtime, the cell join was taking close to 40 minutes. So
Nice.
it slashed that time.
Got it. Thank you so much. Yeah. I think another question is around like, I mean, it's more of a like, I think
Mhm.
curiosity around like the rule-based processing engine. A lot of
Mhm.
people were asking in general about like, so is it more generic? Like, is it something that can be also applied to other systems? Or do you think is it like, and does it involve a lot of like business logic with your current like workloads?
Sure. So we've actually tried to make it as generic as possible. The reason being, we also didn't want it to have overhead on our developers because we were, as I said, right, we were largely using SQL and we didn't want to disrupt it for a lot of people in our team. So what we wanted was that, okay, we still have to write functional code, but we wanted to minimize the amount of code that you have to write. So you can only focus on the custom, on the core logic, and the logic can be translated pretty quickly, right? If you don't have to do a lot of boilerplate stuff. Your case conditions can be converted to if else. You're doing some operations, probably some loops, etc. that you'll have to write, but more or less it's easier to translate the actual core logic. So yeah, and then secondly, in terms of how generic it is, so we've tried to make it generic enough so that Once you pass your input data to the rule processing framework, it takes over.
Hmm.
It has the intelligence of how to execute rules, so it is not tightly coupled to even Spark that much. Hudi that much. We have used it only in Spark, but I think it could also be used in Flink. But yeah, beyond that, because there are some type coupling to data set, data frame APIs, so probably to make it completely generic, we'll have to do some refactoring. But yeah, for Spark workloads, I think it's pretty generic.
Got it. Thank you so much. Yeah. I think a couple of questions were around also using like the custom jars were required, right,
Hmm.
for you, right? So
Yeah.
maybe how to streamline that. Like, did you have any strategies around streamlining that, or even like how you created those custom jars? Like some insights around that.
Sure. So, correct. We had to create two custom jars. One was for the transformer class, and another one was for the payload class. For I think payload class, you still have some references online, but for transformer, I didn't see many. And
Got
luckily, we had some at Uber. We had teams who created like example ones, so we were able to use that. Uh, Basically, certain things to consider is dependency because it's a Java application at the end, right? So you
right.
need to maintain, you need to manage the dependencies properly. How you're building, whether you're building a fat jar, you're building a skinny jar, those are other things to consider. Then the version of Hudi is also important. The first jar that we created was for transformer, which was written in Scala. And again, we use reflection heavily because we want to build this generic rule engine entity, right? So that itself had a lot of problems in terms of dealing with reflection plus generics. So we were using a specific version of Spark Scala, and we had to ensure that Hudi is supporting those things. So I think dependency management was something that came out as something which we didn't account for at all when we jumped into
Right.
implementing it. And I think in general, for starting anything new, I would say have a working example code and then build on top of it. That's the easiest way, wherein you can build
Yeah.
incrementally on top of it, so that you don't face a lot of challenges in terms of setting up things.
Got
But
it.
if there are any more specific questions, you can post. I'll try to answer those.
Yeah. Yeah. Absolutely. Yeah. Thank you so much. Yeah. Once again. Yeah. There is a question, Aryan, maybe it's a bit generic, like how do you deal with
Mm,
partial failures? Did you have something around those? Maybe how do you choose to replay the failed data set? Probably a bit more generic, but yeah, maybe if you have
okay.
seen kind of some kind of learnings from your
Uh,
like implementations.
yeah, I mean, I don't have exactly partial failures because in our case it just fails. But
Yep.
we did had a case which there can be some commonalities between how we implemented a DLQ. So basically, we had to join data, and again, like you're streaming data, right?
Right.
There are no joins in streaming world, right? If let's say your streaming is basically running fast, right? So you're joining with a data set which is, let's say, getting updated every 4 hours, and you're streaming every 1 hour. So there will always be this 3 hours worth of data which will not find a joint data corresponding in the slow set, right? So how do
Right.
you deal with these records? So we introduced the logic of DLQ, wherein wherever we were not able to attribute, we push them into a DLQ, and then next time when we process, we do a union. So
Got it.
that is some way which in which partial failure can also be handled, right? You can for wherever you're having partial failures, as long as you can identify those records, you can push them into a DLQ, do a union, and you can reprocess.
Got it. Got it. Makes sense. Um, One follow-up maybe from Jason is that you mentioned you guys keep 180 days of transaction in
Hmm.
history for incremental query. Is this due to a cost optimization reason or related to like wanting the limitations in terms of like
Okay,
timeline?
I think, yeah, good question, but you're mixing two things. Prior to using Hudi, we were doing 180-day scans. So the reason was we knew that, some records are going to get updates, but we didn't know what's the time range. And based on some statistics, some data analysis that we did, we were able to identify that, okay, for last 180 days, more than 99 point some percent of updates are coming. So let's only process this much data because beyond that, it's although there are updates, but it's very few and too much of a cost, right? If you're
Yep.
not using Hudi, you basically have to read the whole data and you have to scan. So that's a very expensive operation. That's why we were doing 180 days scans. But after using Hudi, the scans are not there because Hudi
Got
gives you incremental data.
exactly. Yeah. So I think you're able to like overall avoid that part and like make
Yeah,
sure you're able to like just do the incremental loads and like process that part only.
correct. And in addition to that, like we were living with some data inaccuracies.
Hmm.
We didn't have data completeness yet, but it was good enough. It was working, but it was not. I mean, this was not the core thing that we wanted to solve. But since
Right.
we were solving for things, we also addressed this.
Got it. Perfect. Jason
I
says
would
next.
also like to add to Jason your question. You did mention something about limiting the amount of commits in Hoodie timeline. So I think uh, the commit timeline, I'm not sure how that will impact because it will still be one commit, right? No matter how many partitions you're writing. For example, now we touch more than 1500 partitions for each commit. So I don't
Mhm.
think like yeah, you will have bigger commit files probably, but the amount of commits that depends on how frequently you're writing, right? So for that again,
Yep.
you have settings like how many commits you want to retain, and also that depends on your consuming processes, how frequently they are running. If the consumer process fails, then they have this time, right? If you're retaining X number of commits, they can only wait for so long.
Yep.
Otherwise, they have to fall back to a table scan. So a lot of factors go into that.
Thanks for the additional context, Ankit. Yeah. I wanted to ask you about like the motivations, like some motivations behind the payroll class, right? So maybe
Hmm.
some context would be great, like just for our like viewers.
So the motivation was that we got very good results initially when the
Yeah.
data was less,
Right.
and then we saw the execution time increase, and that was like counter to everything that we were trying to achieve.
Yeah.
So then, like after studying the Spark logs to see which stage is taking too long, we identified that it was the cell join, and there were certain discussions in our company on how to optimize it, but due to different priorities, nobody picked that up. So we thought that probably if we solve it for our use case and then make it more generic, it can have a greater impact because merge operations are very common for
Mm.
any dimension table. If you're building any stats, it's very common. And without Hoodie, you have to do self join. But we once I got to know that Hoodie is also doing kind of a self join only. So then why
Yep.
do it two times, right? So
Makes
that was
sense.
the motivation.
Got it. Perfect. One question that I see is how do user test and deploy their rule configs?
Hmm. So you can, and what we did was I flashed a stat of 95% test coverage, right? So we wrote all these tests, and since you're writing granular code, you can in fact just test your condition or an action, or you can write a integration test where you're testing everything end to end. But of course, you would want to run with actual data. And there's one huge topic which I've not discussed, which is creating test data. If you have such complex input data, how do you
Yeah.
build test data for it? Very complicated topic.
Exactly.
Like random sampling definitely does not work. We did very sophisticated sampling techniques to build some representation, which would cover, let's say, again, like 99 point some percent of our use cases. And we use that to build a test data. And we run, that's like our golden data set. And whenever we make any change, we have these test suites which runs against that.
Got it.
And by the way, like I don't know about the other orgs, but like in Uber, we definitely have this integration of CI pipelines. So whatever tests you've written do get executed by default.
Makes sense. Yep. Yep. Did you have I know you didn't touch around these aspects, but maybe just a generic thing again, like did you have to deal with like, for example, things like smaller files with like compacting these files, or maybe like
Hmm.
using some kind of like table services within like clustering or sorting?
Yeah, that's a good question. So yeah, we do, and there's this additional cost, right? I also mentioned that we were using record index. That also is a
Yep.
cost. So for small files, so we were using COW table because that is the recommended table in our org, because MOR is something that we are still testing.
Yeah.
But uh, with COW table, there are certain configs. You can do it inline. So we definitely use these compaction services and cleanup services.
Okay.
Uh, but we are not doing it asynchronously.
Hmm.
We are doing it inline. But yeah, I mean, that's one again, that's you can also think of it from the standpoint of optimization or speed. If you want to like
Exactly.
have very,
Yeah.
low latency processes to write data, that is something that could be offered to a async process.
Got it. And just so you touched around like MOR a little bit, like, so are you
Hmm.
considering like using it in the future for some specific, like maybe low latency
Yeah,
use case? Yeah.
definitely this one. So it makes sense, right? The overhead is on read side, right? But again, like I think for later versions of Hudi, like 14, the record index is also used in the read queries, or that's 16.
Oh, yeah, point 14, like,
0.14, right?
yeah,
So, and anyways, like the table that we've created, that's intermediate, that's only for processing. So it's okay if there's some
got it.
overhead on read, but you can get very low latency writes. And I think it takes less space than COW table for sure, because one commit means one file
Yeah,
minimum. So you
yeah,
have
yeah,
those many copies of
yeah.
the file. So MOR makes sense.
Got it, got it. Uh, I know it's a lot, it's a lot of like probably like throwing it on you with the questions, but I think it's
I can
really
take
great to
on
hear
more.
this. Yeah, yeah. I think we just should like take this one more and like let me just pull up anything interesting that I see. But again, like for the
Sure.
viewers, like we'll be like answering this asynchronously as well. So in case there is anything specific for like Ankit as well, we can just leave it there, and I can help like fetch those answers as well. Um, Let me just see what else we have. Okay, maybe one question is around like from my angle is like, do you plan to open source some of these custom transformers in the future? And do you plan to like get like involved in this open sourcing part or maybe something around those lines?
Uh, for sure. I think instead of transformer, the payload is something that I think would benefit more, and which we are planning to. Because
Okay,
again, like I think merge is a pretty common use case compared to a transformer.
exactly.
And I think the transformer that we built is actually pretty basic.
I
The
see.
meat of it is in the rule engine.
Hmm.
Open sourcing that is like a bigger effort, but
Exactly.
probably, yeah.
Awesome. Awesome. Really nice to hear that.
Yeah.
Thank you so much, Ankit, for all the question. I think I was really personally like interested to see like what you are like doing like with this
Mhm.
complex workflows. I understand like at scale it can be like a lot, and I think it's really good to see like Huri being implemented in that way. So it kind of like also helps the community understand like how at scale things are being implemented. Thank you so
Sure.
much for your time and taking all these awesome questions, and also to the community like for like asking these questions and like getting involved in the session. So really appreciate the time as well. Thank you so much. We'll catch you on the next one, and then we'll take it from there. Thank you so much once again, Ankit. Have a good
Yeah.
one.
Thanks.
Bye.
Thanks for having me, and thanks everyone for joining.
Bye, Ankit.